I'm going to go over a few problems from the Math 3, Unit 3, Worksheet 3 handout. Starting with number 1. It asks to write an equation for the polynomial graph shown and determine if the leading coefficient a is positive or negative. So in writing this equation, the key thing is to start with the factors. So we have this polynomial bouncing at that -3, which tells us it's got a factor of x plus 3, but that has a multiplicity that's even. So we can have an x plus 3 squared or x plus 3 to the 4th power, but let's just keep it squared. So we have 2 of the x plus 3's. The next one we have a -1, so that would give us a factor of x plus 1. And the last one we have a x-intercept at 1, which would give us a factor of x minus 1. I'll put that out in front here because I'm running out of room. So x minus 1. So those are our factors. And then if we look at the right end, if the right end is pointed up, the leading coefficient would be positive. If it's pointed down, it would be negative. So we just need to make sure the leading coefficient of this is positive. And the way we've got it set up, we got a 1 there, or you could put a positive 2 there. This would work. And there are many other equations that we could write that would make this work as well. For example, we could have made the x plus 3 to the 4th power. All we need is an even multiplicity to make this thing bounce at the -3. Or that leading coefficient could have been another positive number as well. So this is one possibility, and it works for this answer for number 1. Next, let's take a look at number 3. Number 3, we have a little extra information. And so this graph is crossing through 3 points, where it has 3 x-intercepts, and each x-intercept gives you a factor. So here we have our x-intercepts are 0, 1, and 2. We can convert these to factors. So x equals, if x equals 0 here, then our factor is x. If x equals 1, then our factor is x minus 1. And if x equals 2, our factor is going to be x minus 2. And each of these factors has an odd multiplicity. We're going to assume multiplicity of 1, but it could be a multiplicity of 3 or 5 or 7. An odd multiplicity passes through the x-axis. And so if we multiply these factors together, x times x minus 1 times x minus 2, we almost have this equation. The only thing now is we need to make sure this equation goes through this point at x being -1 and y being -12. So this is y equals something, some number in front of the x to make this work. Right now I'll call it a. And we need to solve for a. So I'm going to plug -12 in for y and a -1 in for x. And I need to plug it in wherever there's an x, so I'm plugging -1 in 3 times here. So we end up with -12 equals a times -1 times -2 times -3. Or -12 equals -6 times a. Divide by -6 and you get a is 2. So the answer, or the equation for number 3 is going to be y equals +2 x times x minus 1 times x minus 2. Next, let's look at number 5. Number 5, it tells us it's cubic, which means the degree is equal to 3. And then we have some points that it goes through. So set negative 7, 0, right here. Negative 4, 0. And 0, 7. And 3, 0. Now every x-intercept gives you a factor and works towards the degree of the polynomial. So if you have 3 x-intercepts, your degree has to at least be 3. It could be more than 3 if it bounces, or if you have more than one multiplicity. But if your multiplicity is 1 each time, your degree has to be 3. So because we have 3 x-intercepts here, we know the graph has to pass through each of these points. So when I draw my graph, I'm going to start with where the y-intercept is. I know from the y-intercept I have to reach both of my x-intercepts. I know I have to pass through those x-intercepts. If I didn't, the multiplicity would be more than 1 and the degree would be higher than 3, and it would no longer be cubic. So that's why I'm knowing that. And then on the left side I have to go back up to my x-intercept, and there are no more x-intercepts, so that's how we finish our graph. So the sketch looks like that. This is going to be y equals some number, I'll call it a, and then each x-intercept is going to give me a factor. So at negative 7, that's going to give me x plus 7. At negative 4, it's going to give me x plus 4. And the one at 3, that's going to give me x minus 3. So you work with your x-intercepts, and then there should, to find a, we want a point that's not on the x-intercept, so I'm going to use that point 0, 7, plug in 7 for y, and 0 for x. And we get 7 is a times 7 times 4 times negative 3. So that is, I'm going to divide both sides of the equation by 7, and I get 1 equals a times 4 times negative 3, or 1 equals a times negative 12. So divide by negative 12, and you get negative 1 over 12 is a. So my equation is y equals negative 1 over 12 times x plus 7 times x plus 4 times x minus 3. And it doesn't matter what order you put these factors in. There we have it. Number 8, we're asked to sketch a graph and write the equation of a quartic. Quartic means degree 4. Function whose graph passes through 0, negative 2. It's going to pass through, so we have an odd multiplicity here. And it's tangent to the x-axis at these 2 points. That's meaning we're going to have, it's going to bounce. Tangent means it touches but doesn't pass through, and so that means we have an even multiplicity for both of these points. And I'm sorry, I was wrong. This has nothing to, this is not even an x-intercept, so we do not have an odd multiplicity there. That's actually the y-intercept, so I need to correct that. So, and let's fix the value here. So 0, -2, that's my y-intercept. X-intercept at 1, 0. And at -1, 0. Gotta get this right here. And at 2, 0. Okay. And it's going to bounce at both those x-intercepts. So we know it has to go through the y-intercept, so I'm going to make this pass through the y-intercept to each of these points. But when it hits those points, it's tangent to them, which means it bounces back. So it's going to bounce that way and down to the left. So that's our graph. So we sketched the graph. Now we need to write the equation. So this is going to be y equals some number a, which we will find later. And then we have x plus 1 squared, because I have an even multiplicity at -1, and so that gives me two factors, x plus 1 and x plus 1, or it could give you 4 or 6, but we're going to work with 2 to keep this smaller. Oh, actually it can't, because we have a degree 4, so we have to work with 2. And then our next factor is going to be x minus 2, and also we have an even multiplicity. Because the right side's going down, I know a is going to end up being negative, but we don't have to factor that in. We're going to find it by plugging in 0 for x and -2 for y. And so here we get -2 is a times 1 squared times -2 squared, or -2 is a times 1 times 4. So 4a is -2, so a is -2 over 4, which reduces to -1/2. So our equation is y equals -1/2, and we said a has to be negative, times x plus 1 squared times x minus 2 squared. It's degree 4, and it meets all those requirements. Number 10, our polynomial p of x is a cubic polynomial, so that means the degree should be 3, such that p of 3 equals p of 1 equals p of 2 equals 0. So that means p of 3, -3 is 0, p of -1 is 0, and p of 2 is 0. So if we split it up, it's saying all three of those are equal to 0, and those are just giving you coordinates. So the first one gives you -3, 0, second one gives you -1, 0, and third one is 2, 0, and you see each of these are your x-intercepts. And then we also have p of 0 is -6, which gives you a fourth point at 0, -6, and that's your y-intercept. So we plot these points, -3, 0, -1, 0, and 2, 0, and then a point here at -6. And it's degree 3, and we have 3 x-intercepts, so we know our graph will pass through each of these points. So it has to look like that. So in writing this equation, we know it's y equals some number a times our first x-intercept is at -3, so we put x plus 3. Our second x-intercept at -1, so we put x plus 1. And our third x-intercept at 2, so we put x minus 2. And then we have a point In this case, we'll use the y-intercept where x is 0 and y is negative 6, and plug those in for x and y. And solve for a. And we end up with negative 6 equals negative 6 times a. So a is going to be 1. And so our equation is y equals 1, but I'm not going to write the 1, times x plus 3 times x plus 1 times x minus 2. And we'll stop there.